Hey y'all, this video is going to get you set up for the chapter review. Now, the questions I'm about to go over are not any, or how should I say that? None of these questions that I'm going to do are the actual questions that are on your chapter review worksheet. But the problems that I'm going to do are very similar to the ones that I am asking you all to work on. So you can try the chapter review worksheet all by yourself, but if you get stuck on a problem or two, then this would be the video that would kind of help remind you and guide you of how to set up and solve these problems. Now, at the very beginning of this chapter, before we did trig, sine, cosine, and tangent stuff, we had problems that looked like this. And we had to figure out how long a particular side was in a right triangle. And we know it's a right triangle because there is a right angle in it. Now, at the beginning of the chapter, we were given two side lengths here. And to figure out the missing side, we ended up using the Pythagorean Theorem. And so the Pythagorean Theorem, the way we first started it out was by saying c squared equals a squared plus b squared. And the c side was our hypotenuse, which was opposite the 90-degree angle. So the x is our c side. So instead of c squared, we have x squared. And in the a and the b, it truly didn't matter which side you picked as a and which side you picked for b, as long as you didn't pick the hypotenuse side. So it was really important to find the hypotenuse first. And then the other two sides, in this case the 15 and the 10, end up being the a and the b. And usually I will personally do the smaller value that I know as a and the bigger value as b. But again, it doesn't matter. You could flip-flop these around. Then what we needed to do was convert the squared numbers that we could actually do in our calculators if you don't know what they are off the top of your head. But 10 squared was going to give us 100, and 15 squared is going to give us 225. And then we could add together the 100 and the 225 to get 325 altogether. And then last but not least, to get rid of the square on the x, we square rooted both sides. So the square and the square root undid each other. And we had to use our calculator at this point. So let me bring up the calculator here. So 325, and I had to square root that. And we went a couple decimal places on these. So 18.0, and then this 2 is going to bump up to a 3. So 18.03 rounded there. All right, so there's doing the Pythagorean Theorem where we're solving for the hypotenuse. The next example is doing the Pythagorean Theorem when we're not solving for the hypotenuse. So we can still go ahead and set up the Pythagorean Theorem, c squared equals a squared plus b squared. But the c side this time, opposite the 90, is the 15. So now I've got 15 squared. And then again, it doesn't matter which one I call a and which one I call b. But usually if a variable is my a or b, I usually like to call it the a value first. And then the 10 will be my b value. Once again, we need to convert our squared numbers into not squared numbers. So 15 squared against 225. The x squared is going to stay put at x squared. Plus 10 squared is 100. Now in this problem, we need to get the x squared all by itself. So we need to first move over the 100 over to the other side with the 225. So that they cancel out over here. And then 225 minus 100 is 125 equals x squared. Nope, come on, squared. There we go. And then last but not least, we can square root the x squared and square root the 125. And again, here's where we need our calculator. I know this is going to be 11 point something and some change here because the square root of 121 is exactly 11. And this is just a little bit more than 121 at 125. So 11.18 to 2 decimal places. And so there's using the Pythagorean Theorem to solve not the hypotenuse. Then we looked at graphing problems. And we would graph 2 points, and I would ask you, what is the distance, the length between these 2 points? So I've already got the points graphed here for you, and this is the piece that we wanted to try to figure out. How long was this segment? Or what is the distance between these 2 points? And if we had a graph, what we did was we just basically dropped down and over to make a right triangle. So from one point, we could drop down until we were horizontally on the same level as the other point, and then we could shoot horizontally over, and we made a right triangle. So here's our right triangle in question. And then all we had to do to figure out the lengths of the legs was just count. So here's 1, 2, 3, 4, 5, 6, 7, 8. So this side has a length of 8. And here's our right angle down here. And this side has a length of 1, 2, 3, 4, 6, 7, 8, 9, 10. And then in these problems, we were always solving for the hypotenuse, or the c side. So over here, c squared equals a squared plus b squared. We're always solving for the c side, so I'm just going to call cc. And then the 8 and the 10 represented our a and b values. So again, we need to convert those squared numbers into not squared numbers. So 8 squared, 64. 10 squared is 100. And 64 plus 100, since they're both on the same side, we can go ahead and add them together. C squared is equal to 164. And then we can square root both sides to get rid of the square. And so C will come out to be approximately, I know the square root of 169 is 13, and this is a little bit smaller than 169, so I know it's going to be 12 point something, 12 point maybe 8, 12.9, let's see, 164 square root, 12.81, rounded to 2 decimal places. So there was doing the Pythagorean theorem when we had 2 points on a graph and we wanted to know what was the distance between those 2 points. And then the last thing in Pythagorean theorem we did was, what if we didn't have the actual graph? And so I showed you guys that if we wanted to find the distance between, or the difference between points, then mathematically we were just saying we need to subtract our coordinates. But we had to end up subtracting 2 sets of numbers. We needed to subtract the x coordinates, and then separately we needed to subtract our y coordinates. So if I had 6 minus a negative 4, now if I subtract a negative value here, I'm really going to be adding this 4. So this is really like saying 6 plus 4 is 10. And then negative 3 minus positive 5. Well, negative 3 minus 5 more is going to take me to negative 8. Now, these 2 numbers that I end up with represent the a and the b of the Pythagorean theorem. But we can't have a negative length in our triangle, so if we ever got a negative result after we subtracted, then we just basically took the absolute value of those negative numbers to make them positive. All right? Now, this ends up being really the same exact Pythagorean theorem setup as what I just did in number 3. So I'm not going to redo all the math again. So I would have just rewritten all this back over again with this problem, and we would have figured out that C ended up being approximately 12.81. Then the second half of the chapter, we moved on to trigonometry, and this is where we needed to know SOHCAHTOA, and that helped us memorize what the definitions of sine, cosine, and tangent were. So in SO, we had sine equals opposite over hypotenuse. Ca was for cosine, which is equal to the adjacent side over the hypotenuse. And TOA was for tangent equaling opposite over adjacent. And so at the top of your papers, you could always quickly write, as long as you remembered how to spell it, SOHCAHTOA. So now let's talk about the 3 different types of problems that we dealt with. All right, so in the first one here, let's see, we've got an angle to work with. So we're going to focus on this 42-degree angle. And so once we found a non-right angle to work with in our triangle, again, we could never do sine, cosine, tangent with a 90-degree angle, so don't even consider that one. Then we labeled our sides, opposite, adjacent, and hypotenuse. So if you wanted to, opposite the 90, I mean, here's the hypotenuse, but notice we don't have a value here. So in this problem, we're not going to be discussing the hypotenuse. But if you still want to label it for labeling's sake, go ahead. Now, the x down here, the other side that is touching this 42-degree angle, if it's not the hypotenuse, it must be the adjacent side. And this 18, which is all the way across from the 42-degree angle, is the opposite side. So after labeling our sides, hopefully correctly, we had to decide, was this a sine, cosine, or tangent problem? And so we had to look at the two sides that we had given to us. So we have the opposite and adjacent sides. So was that a sine, cosine, or tangent setup? And opposite and adjacents dealt with only, exclusively, tangent. So we set up tangent of our angle that we used as our starting point, the 42-degree angle, is equal to, first the opposite side in the numerator, 18, over the adjacent side, x. Now, if what we were trying to figure out was down in the denominator of the fraction, then we had a quick algebraic shortcut, if you will. And we said, and I called this a flip-flop problem, we said we would take this entire trig thing, not just the 42, but the tangent of 42, and we would switch places with the x. So the x now comes over here. The 18 stays put up top the entire time, but now where the x was, that's where the tangent 42 goes. And then that's what we could type into our calculator. So let me bring up my fancy calculator. There it is, fancy. What do we have? We had 18 divided by tangent 42. And we get 19.99 to 2 decimal places. So the x side down there is almost 20. So again, if what we wanted to solve for is down in the denominator, then the quick algebraic move was just to flip-flop it with whatever the sine, cosine, tangent, and the angle were. Just trade places there. And then you'll end up dividing in your calculator. All right, so let's try this one. Again, 42-degree angle down here. Now let me get a different color. Yellow on yellow doesn't work out too well. There we go. All right, now the 24 this time is the hypotenuse, and the x down here, it's still the adjacent. Now the opposite side over here, notice nothing over here, so who cares? We're not going to be discussing opposite sides at all. So now we got to decide, is this a sine, cosine, or tangent problem? So adjacent and hypotenuse exclusively belongs to cosine. So cosine of our angle, our 42-degree angle, is equal to first the adjacent side, x, over the hypotenuse, 24. Now, notice this time around, what we want to know is up in the numerator. So we're not going to be doing any flip-flop. Only if x was down in the denominator do we flip-flop. So now we had to ask ourselves, well, if I want to get x all by itself, I have to detach this divided by 24 from it. So what was the opposite of dividing by 24? Well, we would multiply both sides by 24. So these canceled out over here, leaving us with just our x. And then what we needed to type into our calculator was 24 times the cosine of 42 degrees. And so let's see what that gives us. So 24 times cosine 42 degrees. So 17.8, and then this 3 is going to bump up because this 5 is going to push it up. So 17.84 is how long that side is. All right, and then the last type of problem that we did with trigonometry was solving for an angle. So we're going to focus on this x as our starting point. We don't know what it is, but we're going to use it as our starting point. And let's see, the 8 here is the hypotenuse, it's opposite the 90. And the 5 all the way across from the x is the opposite side. Now this time around, the adjacent side, we don't know, it's not labeled, we don't have a value there. We're going to ignore it. So no adjacents going on in this problem. So now what belongs exclusively to opposites and hypotenuses? That would be a sine problem. So we would set up sine of our angle, but we don't know what the angle is, so we just put x is equal to, first, for sine, the opposite side. So 5 up top over the hypotenuse, 8 in the bottom. Now, this is where we learned a new, basically a function, if you will. If we wanted to get this x all by itself, we had to get rid of this sine. And so what was the opposite of sine? And that was where we had to press the second button on our calculator and the sine button. And it was called the inverse sine. It looked like a sine to the -1 power. So we had to take the inverse sine of this whole left side. And we also took the inverse sine. I'm going to try to squeeze it in here. The inverse sine of this right side. So mathematically, the inverse sine and sine undo each other. This is like squaring a square root or square rooting a square. It's the same effect here. And then we're going to be left with just the x. And then what we're going to have to type in our calculator is the inverse sine of 5 divided by 8. So let's see what that looks like. So let's go back to the calculator. Let's clear this out. So again, to get to inverse sine, remember we had to press second sine. So there's that sine -1. And then 5 divided by 8. I wouldn't recommend using the fraction button with these because if you put in a number that's not a whole number, if it's a decimal number, usually the calculator doesn't like that. It really likes sine, cosine, and tangent to be dealt with really only using division, if you will. So inverse sine at 5/8. Now we got to remember this is not a side. Remember we were solving for an angle. And typically, and if you still want to round this to 2 decimal places, you certainly can. But I recommended for angles we round them to the nearest whole number. So that's what we'll do in this problem. So 38.6, that 6 is going to bump up our 38 degrees to 39 degrees. So x ends up being 39 degrees. Now, before I end this video, I just want to throw out there that if I asked you to figure out how big this other angle was, then just remember that all triangles had 180 degrees, and we could take 180, we could deduct the 90-degree angle that's in there, and we could deduct our now 39-degree angle that we figured out for x, and how many degrees would be left over? Oh, about 51 degrees. And so we didn't have to use another trig problem to figure out the third angle of a triangle. All right, that is all for Chapter I with our Pythagorean Theorem trig chapter. I hope you guys learned something, and I hope you can definitely one day apply maybe the Pythagorean Theorem, but definitely some trig. I would say out of everything that I've ever kind of done in my adult life, there's been times where I've been working on a project or something where trigonometry has really come in handy for me to figure out the length or the angle at which I had to put together either some pieces of wood that I was making, just some sort of structure in my garage. Yeah, I don't know. If you talk to any of the vocational teachers, they would tell me all the time that it's really important for vocational students to know trigonometry, that would really give you really a head start and a jump on a lot of other people. All right, so that's all for this chapter review video.